Hello sir, I'm Urmila Aparao and my lab partner Moma Azik. Today I would like to present lab 3, part 1, part 2 and part 3, and Azik will present part 4. So as for the part 1, let me start up with the given details. So as for the first subnet, we have 25 host IP address. As for the second, we have a minimum of 10 IP address. As for the third and fourth, we have interfaces as loopback 0 and loopback 1, and we also need 2 additional unused subnets for the expansion. So here, how many host address are we needed in the largest required subnet? It's 25 minimum required host address, and for the minimum number of subnet required is 6. And here we got 6 by calculating here employee 1, administrators 1, and all that. We got 6. And the network that you are tasked in the subnet is given IP address. What is the /24 subnet mask in the binary? So here we have 8 ones, here we have 8 ones, here we have 8 ones and 8 zeros. This is the binary for the given IP address. And for the subnet mask made up of 2 portion, the network portion and host portion, this is represented by the binary by the 1s and 0. So the 1s represent as network and the zeros represent as host portion. So as for the 5, here we have the given binary numbers, and here we got the decimal subnet mask equivalent as 1 to 8 at the back, and we have subnet mask of 2, and number of hosts is 126 hosts per subnet. And for the 26, we have 192, and the number of subnet is 4, number of hosts is 62 hosts per subnet. And for the 27, we have 224, and the number of subnet is 8, and the number of hosts is 30 hosts per subnet. And for the 28, we have 240, and number of subnets is 16, and number of hosts is 14 hosts per subnet. And for the 29, we have 248, number of subnets is 32, number of hosts is 6 hosts per subnet. And for the 30, we have 252, number of subnets is 64, and number of hosts is 2 hosts per subnet. So considering the answer which subnet meets the requirement of a minimum host address, it is 25, 26 and 27. This is because 25 actually does not meet the requirement, but 27 meets the requirement because we need minimum 6. So this is the answer. And considering the answer which subnet mask meets the minimum number of subnets required, it's 27, 28, 29 and 30. And considering the answer which subnet mask meets the both required minimum and the subnets is 27, because it's placed in number 6 and also number 7, which has in both, so we considered that as a equivalent number. Okay, now here we can figure out the IP address from the table, and here are my subnet mask, and here are my prefix, and also my subnet dotted decimals are here. Here this I took from the table. And following up for the next one, step 2. Okay, I actually filled up the boxes by the IP address that is that should be filled up in the particular devices. So here is my result for the addressing table for the IP address for the interface, the IP address for the given interfaces, and also the subnet mask that I filled. So next, part 2. Okay, configuring the devices. So first I've configured the router. Let me show you my router here. Okay, first I've configured the router. Okay, so here's the proof of I've configured the router. Then okay, so I've done all these steps. I've done one by one, and that's basic for the part 2. And I've configured the IP address for the PCA, PCB and all. So here is my PCA's IP address, and here is my PCB's IP address. Okay, and then my switch one I haven't configured yet. So this is my router 1's configuration. And okay, now moving forward to the part 3. Okay, we need to ping the command to test PCA whether can communicate or not. Okay, here is the proof that I've attached the ping. Okay, when I enter the IP address, it can ping successfully with 0% loss. And here verify the connectivity. Yes, it's successful. Do you get a reply? Yes. Okay, next to test PCB, okay, I've done the same thing for the PCB as well. So when I ping the IP address, I got a 0% loss, which means it's a successful. So do I get a reply? Yes, I did. And to test whether PCA can communicate with PCB, here's my ping picture with also 0% loss. So yes, did I get the reply for all this? So consider all that are successful. Okay, next, experiment by purposely misconfiguring the gateway to PCA. Okay, what happens when you try pissing? Okay, when we does this, we eventually won't get any reply from there, because it will only the flow will be only until here to until here before the router. So we actually won't get any reply from there. So that's the answer for the E. And okay, that's all. That's the basic thing of for the part 1, part 2 and part 3. And here I've attached the IP address, particular IP address for the devices. And if actually this concept is some sub networks require many IP address and other requires only a few. And when we having all the subnets with the same size, it's not most efficient way to divide the subnets and all. So that's why we have many subnets, mask, and also all that with the decimal point. So that's all for the part 1, 2 and 3. I've go through the report. So part 4, Aziz will continue. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz bin Muhammad Zaki. I'm partner with Urmila. Okay, for part 4, it tells us to design the VLSM address scheme, and the requirement for it is the same as part 1. Okay, this is the information that we given. First subnet minimum 35, the second subnet minimum 10, and for the third there are 2, which is 5 and 5 over here, 5 5, and then the rest is 4, there is 2 also. Okay, the first one is already been given, so from 25. After that, we get number of host bits we get from this, and then we convert to 1111, and the rest of 1 is the number of host bits. And then we use the formula to calculate number of hosts, which is 2h, which is this one, and minus by 2, and then we got 30. Okay, and we do that again for the rest. Okay, and this is the same requirement as the part 1. So we make the topology same as this over here, and we use the same addressing table as part 1. Okay, after configure, assign host name, make sure the IP address already, and then save. After that, we check whether we can ping or not. First we check to see PCA to default gateway. So PCA to router, I already checked, it is over here, ping 033. You can see over here is 033 G0133. Alright, and we got reply from it. After that, from PCB to router, this is G00, which is the ping, the IP address is 101, and we got reply from it also. After that, from PCA to PCB, so PCB is 192.168.0.30, and we got the reply of it. So all the ping is successful. And for reflection, the first question it is asked, why is the subnet mask so important when analyzing an IPv4 address? So the answer is we need a subnet mask for IPv4 addresses because the address doesn't give any information on the network size. Also, to be clear, the purpose of the subnet mask is to determine which hosts are on the local network and which are outside of the network. Second, what information is needed when determining an appropriate addressing scheme for a network? The answer is you will subnet the network address and provide an IP addressing scheme that will accommodate the number of subnets displayed in the topology diagram. You must determine the number of bits to borrow, the number of hosts per subnet, and potential for growth as specified by the instruction. Question number 3. Subnetting one larger network into multiple smaller subnetworks allow for greater flexibility and security in network design. However, what do you think some of the drawbacks are when the subnets are limited to being the same size? The answer is some subnetworks require many IP addresses and others require only a few. Having all of the subnets the same size is not the most efficient way to divide the subnets. Question 4. Why do you think the gateway or router IP address is usually the first usable IP address in the network? The answer is the default chosen by the manufacturer is normally either the first usable addresses or the last usable addresses in the subnet. Question number 5 is what is the advantage of using VLSM subnetting? And the answer is VLSM provides many benefits, mainly related to how you allocate and use your IP address space. Because a must define the size of the subnet, VLSM allow engineers to better match the need for addresses with the size of the subnet. For example, for subnets that need fewer address, the engineer use masks with fewer host bits so the subnet has fewer host IP address. This flexibility reduces the number of wasted IP address in each subnet. By wasting fewer address, more space remains to allocate more subnets. Okay, that's all from me. Thank you.